Okay, so first of all, is this a function or not? Give me thumbs up or thumbs down. It is a function. Good, it is a function because look at these ordered pairs, right? If we have a t-table like this, these just act like ordered pairs, right? And another way this question could be written would be if you just had a set of, a bunch of ordered pairs, it could have been presented that way instead of as a table also. But look, each input only has one specific output. In other words, input X values are not duplicated. They only ever show up one time. And so, yeah, it is a function. Okay, next issue, graph or give the domain. Okay, so select the correct answer. Well, there's our function. Well, is the domain, and this came up a lot on that assignment. Did people, I think when they originally were working on this, a lot of times they weren't sure which of these to choose. Well, which one do I choose? Do I need to use a set for this domain or an interval? It's a set for sure. How come? What's the difference? How would you know when to use a set versus an interval? Okay, yeah, a set is what we use when there's a just specific values. There's like a list or a collection of specific values, right? So anytime you're given ordered pairs like this, it's always going to be a set. Or if you had a graph that had individual points, that would be a set because they're specific values, right? An interval would be if you had a graph where there were an infinite number of numbers in the domain. So I have to define them like as all values, x values greater than 2 or something, right? Where I have to define them as an interval of an infinite number of values. A set is if there's a finite, countable number of specific values. So this is definitely, I have to use a set on this. Okay, and what is the set? Well, it's just those values, right? So inside the set brackets, I'm just going to include each of the numbers in the domain, and we just always separate the stuff in a set with commas, right? You separate the pieces or the elements with commas. So what about the range? Look at the range up there. Is the range going to be a set or an interval? It's going to be a set. It has to be, right? How many values are there in the range? Well, but they're all the same. So one value, right? That's a set. That's not an infinite number. That's one. So definitely it is a set. And it's only got one value in it. It's just 6. So inside our set brackets, it says 6. And you guys get right that when you see these kinds of brackets like this, these squiggly script brackets, that's means it's a set, right? Okay, give me 1 to 5 on that one. How are we doing? Okay. How about this one? Now we're given a graph. So is this, give me thumbs on this. Thumbs up for function, thumbs down for not a function. Is this function? Correct, not a function. How come, Carmen? You got this. But how can we tell real easily? What test does it fail? Go ahead, Josie. The vertical line test, right? If I drag a vertical line across this function, because the vertical line intersects, because the vertical line intersects the function in more than one place, it fails the vertical line test, right? If it's a function, a vertical line can only intersect the function at one place ever, right? So this is not a function. Okay, what's the domain of this one? Is this a set or an interval? It's got to be an interval, right? Because it's got an infinite number of values in the domain. It's not just like the values 2 and 4 and 7 or something, right? It's an infinite number of values. Now notice it says type your answer in interval notation, not as an inequality. It wants it in interval notation. So Ellie, how could I write that interval? How could I write that domain? Negative infinity. Now the domain. So negative infinity, I'll buy that. The left endpoint of that domain is negative infinity. But what's the biggest x value? 4. Okay. So it's going to be negative infinity is my left endpoint, up to positive 4 is my right endpoint. Uh, Karsten, what kind of enclosure am I going to need on the 4? Is it going to be a parenthesis or a bracket? On the 4? Yeah. Okay, so that if it's a parenthesis, how come? A close point goes with a bracket, right? Okay, so no, so you're thinking the right thing, but remember how we can always put that stuff together, right? Everything that takes more ink goes together. So it takes more ink to draw in the point, takes more ink to draw the bracket, right? Okay. So it's a bracket because 4 is included. If an ant is walking on this graph, could the ant ever get to a place where the x coordinate is 4? Yeah, right there, right? So we need a bracket. Okay, now what's the range? What's the range of this one? Hey, but what's the range of this one? Now keep in mind, keep in mind these arrows. Exactly, negative infinity to infinity, right? It's all real numbers because what do these arrows tell me? This thing keeps on going to the left and expanding, right? So if I zoom out far enough, there's no y value I couldn't see on this graph if I zoom way out, right? So that's the range using interval notation. That's how we say all real numbers with interval notation. Negative infinity to infinity. Okay, flash me a little 1 to 5 real quick. How we doing? Okay, okay, all right. We're getting in striking distance. It's just a matter of finishing this review. If you haven't done the review, you can see how important that's going to be. Okay, here's a function, y equals 4x minus 5. That includes the ordered pair 7 what? Well, how can I solve this one? This is really easy. Okay, and what? How? What am I going to do? You're right. Keep going, Ellie. You're right. Say it. No. What do I set x to? 7. Yeah, right? Because look, there's my input value. If I think about an ordered pair is always of the form xy, right? So then this 7 is just my x value, okay? So y is just going to equal 4 times 7 minus 5. Well, that's 28 minus 5. That's just 23, right? Let me see how that works. Okay, just remember, ordered pairs are always input value is the x value, output value is the y value, okay? All right, this is the exact same question, just asked a little bit differently. This time they're giving us the function in function notation. G of x equals negative x squared plus 5x plus 1. And it wants us to find and simplify g of negative 2. So Ellie, what am I going to do here? There you go, plug in negative 2 for x, right? So all we're doing here is negative 2 is going in for x. So what's our rule when we do this? We talked about this, but I think I only said this one time. I want to really reinforce this. If I want to calculate g of something, g of negative 2, then I'm going to write my original formula, right, my original function. But when I'm plugging something in, every place I used to have an x, I'm going to leave an empty quantity for dumping a value in, right? So what do we get? Negative, but instead of an x, that's just going to be some quantity. So I got an empty quantity where the x used to be, so I can pour a value into that. Plus 5 times whatever my x value is, plus 1. You see the pattern, right? Same thing we started with, but every place I used to have an x, I've now got an empty quantity. What am I pouring into those empty quantities? Negative 2's, right? And then I just have to simplify that. So when we simplify, of course, we have to follow order of operations. And it's just regular simplifying order of operations. So starting at the top, can I do anything inside the parentheses? No, there's nothing I can do inside the parentheses. Next step, exponents. Yes, I do have an exponent, right? Now, what am I squaring here? -2, right? This is what's being squared. So -2 squared is +4. But notice I have to do the exponent before I can do the multiplication. Okay? So I end up with this equals negative, and then when I squared that out, I just got a 4. Okay, the mistake people make sometimes is they want to distribute the negative first and then square it, but that's not the order. We have to do the exponent first and then multiply by the negative. So I get -4, and then the rest of this is pretty straightforward. +5 times -2, that's just -10, plus 1. So I get -14 plus 1 is what? -13. Okay, good? Make sense? Okay. Okay, super easy. Look, they're just giving me a set of values. Again, look at the notation here. I've got these set brackets. So I've got a set of how many things? Show me with your fingers. How many things are in that set? 3 is correct. 3 is correct. There's 3 things. How do I know there's 3 things? Because all the things or the pieces are separated by commas. So there's 1, 2, 3 things. Each thing is an ordered pair, right? Each element of that set is an ordered pair. Okay, so we know ordered pairs, the input values are the x values, right? So this is my input, and this is the y value is always the output. So what is this really saying? Find f of 9. What's another way I could phrase that question? What am I looking for? Okay, I'm looking for the y value or the output value when the input value is what? 9. That's exactly it, right? That's really all I'm saying here is find the output value when the input value is 9. That's it. Well, what is it? Yeah, it's 7, isn't it? It's 7 because of this ordered pair right here. If I input a 9, I output a 7. It's just that easy. Okay? I think this test, to me, is way easier than the last test, personally. I feel like it. But I tell you what, if you haven't done the review, I don't predict you do very well. But if you've done the review, man, I don't see how you could go wrong on this one. It's really not very complicated stuff.
You just want to jinx me by saying that, will you?
No chance. No chance. Okay, what about this guy? Same kind of thing, right? This time we're just using the graph to find the output values. So what's the first question asking me to do? Find the output when the input is -3. In other words, I'm finding the output, the y value, when the input x value is -3. So what is it? 0, yeah, because look, there's the point that we're interested in. That's the point with an ordered pair, 3, 0. So if I input a -3, I output a 0. Okay, next one. This time I'm inputting what? So what's the output? 6, right there. That's the point that tells me the ordered pair is 0, 6. Okay, next one. Nadia, what's f of 5 then? Why 0? If I'm inputting an x value of 5, So where's the point on that graph with an x value of 5? Tell me when to stop with my x value. Oh, I mean, okay, do you see why though? Because look, there's x equals 5. So if I go up to that point, that's the ordered pair with an x value of 5 and a y value of 4, right? Okay, so 4. And how about the last one here? Owen, what's f of 6? Yeah, 6 right there. Good. Because the ordered pair is 6, 6. Good. That's probably not good. Okay, good. So yeah, we got the point 6, 6. So there we have it. Okay, one more, and we'll call her good for today. So write an equation of the line in standard form with integer coefficients. So there's our starting place. We got to think ahead. What is standard form? Julia, do you remember real quick? Do you remember what standard form is? Say it one more time. Y equals mx plus b. That's slope-intercept form. Standard form was that first one we talked about. I'll get you started. A plus by equals c. There we go, right? There's standard form. Okay, remember the rules for this. For standard form, a, b, and c have to be integers, can't be fractions, and a has to be positive, right? So the first thing we got to deal with here is, well, look, we got a fraction. So how do I clear fractions? What am I going to do to clear these fractions? Leah, what are you going to do? Multiply by 3. Yeah. If I look at all the denominators, there's only one denominator. The least common multiple of the denominator, so the least common denominator is 3, right? So I'll just distribute a 3, which is the same thing as 3 over 1 if I want to think about it that way. Distribute that through. Well, that's easy. 3 times 5y is 15y equals, okay, now how about this one? Let's just do regular distribution this time. 3 over 1 times 8 over 3, I multiply straight across and I get 24 over 3, which is 8. So 8x, and then finally minus 24. 3 times negative 8 is negative 24. Okay, good. Now what? I got to get the x term on the left side, so what could I do? Okay, I got to subtract the 8x from the right side. Got to get rid of it on the right side, agreed? So if we subtract 8x from both sides, what's that give me? Well, the 8x's cancel. How about on the left side? Those are not like terms. I get 15y minus 8x, but I want to put the x term first, right? So why don't we write that instead as negative 8x plus 15y. And on the other side, I've got a negative 24. What's the one last rule that we're breaking? Needs to be positive. Okay, so Nathan, A's got to be positive. So what do I need to do to this equation to make that first term positive?
I just looked at answers. Sorry.
What's all right?
Do you add? I mean, minus 8. Right?
No, I mean no. What do you have to do to that term to make it positive? Say it again.
Oh, okay, yeah. Then you add it. I thought you were trying to get a positive. That's fine.
That's what we're trying to do is get a positive, right? So what do I have to do? This first term has to be positive. What do I do to make a negative term positive? Okay, divide by negative 1 or multiply by negative 1. Same thing, right? But I have to just treat both sides equally. It's an equation. That's okay to do. I can. It seems arbitrary to multiply or divide by negative 1, but as long as I do the same thing to both sides, that's a legal step, legal algebra step, right? So last thing, I'm going to show it as multiplying. I think it's easier because then you can think about it as distributing something, right? If I distribute a negative to an equation, what's that do? It just changes the sign of each term. So I'm going to get positive 8x minus 15y equals positive 24, and that's my answer. Okay, good? Does that make sense? Okay, I'm going to call her quits there. You guys work, get questions answered. Tomorrow we'll finish this up, and you'll get a little bit of work time then too.